It's time to go all in on AI engineering. If you go on LinkedIn, all I'm seeing right now is a bunch of people that's getting 200K plus an annual salary in AI jobs. And you want to know how are they doing it, right? And the thing is, for me, I did basically a 3-month transition from my industry, which was 3D and computer graphics, VFX, AAA games, into AI engineering. And I'm going to show you how to do that. So I'm going to tell you the basic blueprint. You need the right skills and you have to have the right projects. So the thing is, when I started, I learned ML and basically ML science, meaning like machine learning, data science and whatnot. That was 10 years ago. And that was, you had to learn at the time, you didn't really have much frameworks. They're only just coming out, like TensorFlow and PyTorch and Scikit-learn. But when I did it, you actually had to code. So nowadays, it's a lot more accessible to people, which is good because it's been a decade and all these models are available now where we had to build it from papers or from scratch. But the other thing is it's super competitive. So it's accessible, but that means it's now flooded. It's hard to tell the signal from the noise. You want to be able to stand out from 95% of the people there, because what's happening is now people are doing the same projects, showing the same type of thing. They go on YouTube, they look at it, which is great to learn, don't get me wrong. But then they take that and try to apply for a job. So when you see at the time when you only had maybe hundreds of people applying, now you have thousands of people applying and they're looking like exactly the same. How do you stand out? How do you get the signal from the noise? So this is how to do that. Let's first talk about the tech stack or the technical stack or the reality of what you need to know. First of all, these days, you probably want to be a builder, not necessarily a researcher. This actually happened to me not too long ago. A friend of mine said he wanted to learn machine learning, deep learning, become an AI engineer. And he showed me a bunch of things that I had to learn to actually get into it. The thing is, nowadays, unless you're going to actually learn the math yourself and you're going to become a researcher and work at these big labs to train these models, you don't want to necessarily learn the actual math like in super high detail. You should understand it and work. That's why we're going to do like the basics of it. It's kind of like if you want to be a driver of a car, you have to understand kind of like a little bit of how the engine works just to maintain it, to change oil and all that, or else it might break down. But you don't want to be a mechanic. You don't want to go to school to necessarily be a mechanic. You want to be able to actually do your job. So companies are looking for builders to actually have something, an end result that actually work. You have to understand how to use the models. You don't necessarily have to build it itself. And here's basically, I'm going to talk about the practical AI tech stack that you should know and how to actually work with it, right? And the other thing about this, I want to mention is that you learn the basics, but then AI is changing so quickly, so much that you kind of like be aware of what's happening, but only learn in detail just in time when you actually need it, right? So let's get into the actual tech stack. The industry standard right now is Python. Yes, there's many different languages out there, but if you're going to learn AI and machine learning, Python is the industry standard. Specifically, the actual framework that's being used for machine learning is now PyTorch. Like I mentioned before, when I started, I actually had to code this from scratch. There wasn't an actual framework, and when you did it yourself, you actually have to implement the actual layers yourself to forward propagation, back propagation, all those things, all by yourself to figure out the gradient. You don't have to do that now. And then TensorFlow came out, and which was from Google, and it was a popular framework still around. Then PyTorch came out because of the way it works, a little more Pythonic, easier to use. And then TensorFlow, even their second versions kind of copy their style. But basically, the reason why you say PyTorch, the state of the art of papers right now, they use Python and they use PyTorch in the back end. If you're going to look at like the state of the art of papers that are the new research that are coming out or the new models are coming out, they're using this framework. The other thing you want to learn, be aware of, is a LangChain. It's basically an LLM, a large language model app, Swiss Army knife. So it basically is built on Python and JavaScript to basically link together all different large language models, right? Then the other thing you should be aware of is also Docker, because this actually eliminates the need of like, well, it works on my machine and not someone else's. You're able to containerize that and basically have the whole ecosystem inside that and give that to someone else for it to work. And the other thing is cloud basics, because machine learning, deep learning, all these models, they work at scale. So most likely you don't have your desktop computer, especially your laptops, are not powerful enough to run these Dockers. You may be able to run these Dockers or these models or this tech stack. You may be able to build out the framework for it, but to actually scale it up at a large scale, you're going to need to know how to use the cloud basics. So something like AWS or Google Cloud platform, or as well as Azure from Microsoft, you should know how to use those. And as I mentioned before, once you know these basics, everything else you got to learn just in time, because literally every week new things keep coming out, and you have to learn how to bring that into your system. So I'm going to walk you through the project that actually changed everything for me. This is a real world example, right? So I created an AI agent that worked on real workflows on my own industry. I started off, the first AI project that I worked on was in actually working on like the stock market and all that. But then I started applying this to multiple other projects because companies kept approaching me saying, hey, we had this problem, can we solve it? And the one I came from was 3D animation in video games and in VFX and feature animation. So there's something that always happens. I was the CG supervisor for Teenage Mutant Ninja Turtles Mutant Mayhem. And one thing, we wanted to automate the 3D production. And not just that project, many other projects does this, right? So we want to automate the 3D production of it, right? And I'll give you one example of how this works. So basically, we wanted to be able to take concept art, that's the drawing of what a character would look like. And in a traditional sense, what you would have to do is someone has to model it out, and then after, do the texture so it would actually paint it, and the materials are looked at or surfacing so it actually wood looks like wood, and like metal looks like metal on the type of characters and their clothing. Then they rig it. That's basically articulation, basically making a digital puppet. So then you could animate it. And this is a preview ROM. That basically a ROM is a range of motion or a calisthenics, so you actually see how the character or the puppet would move, digital puppet would move. So now, was it perfect? No. And was this used as a final asset for the movie? No, not at all. But what this allowed us to do is on day one, we're able to take a concept art, create a model, have a texture, make a rig, a digital puppet, and have it move, and you could see it. And everybody, all the relevant departments could look at it and make an assessment of that, and then say what needs to work, what doesn't work of the concept art. Because especially of the concept art, it's you're making up things that don't exist in real life. So when you actually try to make it work with like the rest in a 3D world, especially in VFX where you're mixing it with other real live plates, it might not actually move correctly or look correctly. It doesn't work, translate well. This pipeline allows you to preview that. You see the key part is preview. It doesn't replace artists at all. It's more, it was an enhancing tool that, okay, now normally if you have to do this manually, you would have to wait weeks, sometimes months before you get down to the stage before you find out like this doesn't work, the concept art doesn't work, and you have to go all the way back to fix it. Now you can do that on day one and literally save weeks or months, plus a lot of like man hour, women hour, like people hour of development time just to eliminate problems. That was a real time saver and a game changer for that, right? So again, was this perfect? No, it was not perfect at all, right? It didn't have to be. It basically just give you an idea of where it would go. So the gotchas, the things you would look out for. And so when you actually do the real project, you kind of step over. It's kind of like stepping over the landmines. If you know where they are, you could avoid it and you could get through the field a lot easier, right? Did it solve a real problem? Yes, it saves a ton of money on the production for it. It saved a ton of time. And now people could focus on actually being creative and making the fun stuff of it, as opposed to all the overhead of trying to get it to work, because it wasn't, you have to you're spending your time trying to fix problems and patch things, right? So for you, your domain is your superpower. In this case, I knew 3D, right? So I knew already the whole process, how that worked. Now using AI on top of that was to help basically enhance the experience enhance the tools to make the people already there a lot more efficient and give a much better quality output and focus on what they actually wanted to do. It solved real problems, right? Now, the thing is, if that's the part that separates you from what I was mentioning earlier, where everyone's doing the same type of 3D projects to apply for jobs, if you know your domain and you know your real problems in your domain and use the AI blueprint applied to your domain, because I don't know your domain, you'll know better than I do, and you solve real problems, people will pay attention. Do it in your field, and that's how you'll stick out. Now, here's a very important part. You need to be able to market yourself, right? Marketing made people know that you're actually doing AI and you're actually solving real problems. And the best place to do it is LinkedIn and Twitter. LinkedIn is a lot more professionals, that's where the business people are. And Twitter, because they're such short form and get bursts of information, you're able to give like quick updates on this. And the thing is about this, you want to share real problems and solutions to those problems, right? And the main thing you want to show is results and the metrics. Metrics meaning this is the end result of it, and this is the metrics before your solution and after it to show the real impact on it. So to actually do this, right, what to actually post on this stuff, right, to market yourself. I wouldn't go out there and say 30 days of like coding Python, and put like 100 days of coding and all that. That's nice. Or, it's good that you're doing that. You might want to be doing that, right? But this is kind of like if you're trying to be like a top hockey player and you're like 100 days of skating, like you kind of need to know how to do that stuff. That alone doesn't get you the job, right? What actually gets you noticed is that you show on your post solutions to real problems, right? You show the end result of like a real problem, right? You could show implementations of papers, right? So that doesn't necessarily mean you have to go build the model yourself, or you could find a model that is using that that state-of-the-art technique and actually applying it to a solution in your domain space to a real problem, and say, hey, this is how this could be applied. Because the things about papers, academic papers about this, is that a lot of them they're not generic. It's more they're not solving a specific problem. They're usually trying to beat a metric on the last state of the art, right? It's up to us, or basically to someone, a company wants to be able to implement that and actually solve a real problem, which a paper doesn't necessarily map the real problems and what actually is needed in real life. That's where you come in, right? And like I mentioned before, the most important part, you want to show the before and after metrics for your project. So like this is without your solution, how long it took, how expensive it was, or whatever. And then the impact after and how much better and more efficient it is. That's the whole point of this, right? That's what companies hire you for, right? And you could show your actual code that works, or sometimes you might not necessarily do it, maybe just some parts, or just talk about it, depending on how proprietary you want that to be. But mainly show the results, I would say. I would actually probably show more results than code itself. Or like even if you show the code, you just could show kind of like this is the code that's doing it. You don't necessarily go step by step through that. And again, show results and metrics. That is what's important. That's what companies are looking for. That is what gets you hired. That's what they're looking for, right? It's companies hire to get a result, not just for someone to sit down and just do research, unless you are getting hired for research. I want to talk about the uncomfortable truth of it all, because high level, it doesn't seem that hard to do, right? But the thing is, like, in fact, it's not really that hard, right? Learning is not hard. You could go on YouTube, watch a bunch of things. The difficult part is staying consistent with it, right? The part about that is that, especially now, if you are already working and you already have a job and you're like, okay, I want to get into this, right? There's no real immediate motivation for you to stop, like your do or die type situation. Is that if you decide not to do anything today, there's nothing that will happen to you, at least not today. And I've seen this happen with a friend of mine where he wanted to achieve something in his career, but where he was already, he was very comfortable. His lifestyle was great, quality of life is great. And then, which happened to a lot of us at one point, then they were downsizing and a lot of his position got redundant. So he was let go, right? So he kind of came out of nowhere. Yes, he had severance pay, that's fine. But then all of a sudden it became real. And the thing he revealed to me is he said, I wish I actually went and pursued what I wanted to do. But he didn't at the time because he was too comfortable. Now he actually did finish what he needed to do, but it took that situation to get like pretty much light a fire under him to actually get that done, right? That's the hard part, is that if you don't have that at the moment, if you're not in a do or die situation, and AI is already here and you have to learn it now, you don't want to be too late about it, right? So what I would suggest is don't learn it alone. Like, actually take it seriously. Find other people who are serious about it so you can have accountability. Find other people who are hungry as well and have accountability with each other. In fact, I have a couple of interns right now who want to learn how to do these things, and I'm giving them accountability of giving this exact same blueprint of what you need to do and follow through with it. right? Because they're already comfortable in their own ways. But if they want to see results in the near future, they have to do things now when nobody's looking. I mentioned that I have like interns already going through this. So what's the real path? What is kind of what I'm doing? First of all, I want to mention web development versus like AI opportunity. Is web development important? Yes, it is, still is. Web apps is still kind of universal. It's still really great. But what's happening right now, our companies are looking for AI opportunities because you could find a dime a dozen right now of web developers. It's still very important, but everybody's looking for AI opportunities. They don't. The thing is about is they don't exactly know what they want it. They just know they want it, right? So if you're able to provide it in the format like I mentioned before, you have a solution to problem. You're actually solving something domain specific, especially if it's your own domain and you know the problems and you could solve it with AI. You're bringing real value to the company, and you can show the before and after metrics of without your solution, then with your solution. You're going to put yourself in a big position that you're going to stand out from everyone else, right? And at the end of the day, you want to show that you could actually ship real AI systems, right? So how do we do that? So here's the actual plan that I suggest, and I have people doing it. Month 1, you're going to learn Python, right? You learn the basics of it, and you also, not only just Python, not just generic Python. Well, you're going to need to know how to do that in general, but you need to know enough and to be able to do these things specifically. The data science basics, NumPy, if that's numerical Python. Because if you, for example, math and pure Python, if you ever did programming, people say, oh, Python is slow versus like C or C++. Not if you're using NumPy. It's a lot faster for it, right? That's why, and Python's a much easier language to learn. And then Pandas, that is, you're able to take like Excel sheets or Microsoft Excel sheets or spreadsheets and put it in, which is built on top of NumPy to do a lot of data analysis and statistical analysis a lot faster than if you just did it in Excel, right? So these are kind of like non-negotiables. You have to learn this because this is the tools of the trade, right? So learn the basics of it. Then month 2, once you have that built on top of that, now you start learning machine learning fundamentals or deep learning, which is kind of like the coined term from machine learning. Basically, it's neural networks. Deep learning, if you have more than 2 layers, they call it deep learning. At least that was the buzzword a decade ago, right? But basically, it's machine learning, right? And the basics of it again, because in Python you have different packages or modules that, for example, you could one of the packages is NumPy, the other one is Pandas to download, another one is scikit-learn. So when you're first starting to learn machine learning basics, you start off with these, and you have pre-built models already built into there, right? So you got to learn the basics of these models, how they work, and the general idea of that, right? Once you go into month 3, now you start getting into a little more like actual tools that are today's being used, right? So again, deep learning is machine learning. You just if you have more than 2 layers, they call it deep learning. And LLMs, right? Large language models. That's what's kind of dominating right now. And the main framework for that's being dominated right now is PyTorch. That, like I mentioned earlier, all the state-of-the-art papers, they're using it. Before it was TensorFlow, but now everyone's using PyTorch. Again, this was developed by Meta or Facebook, and it's more Pythonic. So if you learned how to use Python, right, a lot of the methodology of how it works is still the same in PyTorch. And you want to learn basically the transformer model architecture for models, or like for AI models, right? Mainly because as of like the academic paper was released around like 2018, that kind of changed the world of architectures. From then until now, this is still like the dominant form. Before that, and like even like one of the state of art before that paper, like it was like LSTMs, like long short-term memory. That's a way for machine learning to learn and to maintain, not just learn it one shot, but actually have some type of memory to recall things beforehand. Transformers, just learning how it works. You don't necessarily have to learn how to code it and build it from scratch, but learning how it works is very important because that's the dominant architecture now. And the other one is LangChain. I mentioned this earlier. This is pretty much a framework that uses Python and JavaScript, because I mentioned front end is still, web development is still like an important part, but it's a framework that allows you to work with different large language models, because these are basically what's happening today, right? So once you have that, from month 3 to 4, you're gonna basically just jump in there and jump in the deep end. And from 4 months, you're gonna feel comfortable? Not exactly, but you know enough to start things going. It's gonna be slow at the beginning, yes, but you know at least of them a little bit of the foundation, enough of the foundation to start building your own real projects. So choose a project. I highly would recommend something specific in the domain you are powerful in, because you know it the best. It's going to make it the most unique, right? And I would say start building 3 projects. At this point, that is when you start applying. Yes, start applying even when you don't feel comfortable. And this is important because it's going to take time before people are going to actually react to you, or you're going to start sticking out and becoming a signal from the noise. You don't want to wait last minute when you feel comfortable, because by then it's going to take too long and it's too late. You want to build it because you don't know when opportunity is going to come. Opportunity is basically when you like when they say luck, actually. Luck is when preparedness meets opportunity, right? So the thing is, this part here is making you prepared, right? This is the prep that you're doing here. And this part is creating the opportunity, right? And now the part of that is that when people say like, oh, you're so lucky, is when basically opportunity meets preparedness, is that you're actually manufacturing this yourself, right? You are being prepared while you're creating opportunities that at one point when they finally align, then you're lucky, right? So create your own luck by actually going through this, right? So get lucky. Here's your blueprint, basically your to-do list, right? Learn the basics. You do this for 3 months, right? Then from here, build domain-specific AI solutions. This is what's going to make you stand out. You know your domain the best, right? You'll know it better than I do, right? This is going to make you stand out, right? Do this from month 4 plus. Is it going to be great the first couple? No, but you could keep doing it, right? The other thing for the marketing part is very important. Document everything publicly, right? I mentioned before, LinkedIn, Twitter. Why those specifically? Because that's where the professionals are, right? LinkedIn, that's basically the professional social media, right? That's where actual business gets done. And Twitter, because there's such short form bursts, it's quick updates that business people are very busy. They don't have time to sit down and doom scroll, right? So that's why. And you continuously do that, right? Remember, like I mentioned, you're doing the preparation. This stuff is the prep. This stuff is your opportunity. That's how you create your luck, right? So this is your prep right here. And this is your opportunity, right? And from this day on, you gotta, just do a quick post what you're doing. And then after you apply to 5 jobs daily, starting from month 4. Take it, apply for 5 months. Everybody I know who's successful, high executive positions, what they do in the morning, they block out time, 1 hour every day. They get up and apply for 5 jobs and just strategically, just routinely do that. And it builds up over time. You're not going to get answers at the beginning, but when it starts coming in, it's going to seem like an avalanche at one point, right? And the thing is, you keep doing this stuff while you wait. You keep going while you wait until something happens. It sounds simple. And like I said, the actual concept itself is simple. What's hard to do is actually stay consistent with this until it works, right? That's where most people fail. That's how you want to be the top 5% or top 1%. This is where it's at. You're not necessarily smarter than everyone else. You're just working in a much smarter way and consistent at it until it works. Because the thing is, once you finally get the job and you actually get into it, this is a lot easier because now people are going to look for you because you've been proven. You have the blueprint. Right now, start building AI systems. Don't be on the sideline looking at other people and seeing on LinkedIn and seeing like, wow, this person just landed another 200K annual salary doing an AI engineering job. What's the difference between them and you? They actually got up and did something, right? So, and it's within your grasp, and I gave you the blueprint on how to do it, right? So what I say is shoot your shot, right? What's the worst case scenario is that you are where you are right now, right? So it's pretty much, you're not going to get worse. You're going to be more informed. The world is moving towards that, right? And the best case scenario is that you get into this industry and you future-proof your career.